All right. Okay, so now we're going to talk about radians as rotation angles and not just changing degrees and radians, but just like, no, you'll see. Just like a regular angle, it can go all the way around. It always starts, standard position is still the same place. It's 0, it's right here. It always goes counterclockwise. 0 is the same in degrees as it is in radians. Only difference is, in degrees, it has a little degree symbol. In radians, it's just 0. That is the only angle measure that's the same. Everything else has its own different measurement. Now, on here, they have divided this up into, these are 12ths. So let me show you something real quick. You don't have to write any of this down, but I just want to, I think this will all make sense to you if you understand it geometrically. So this is a semicircle. Pretend it's perfect. And remember, so this is 0. And remember we said it took 3.14 to get to pi. So a semicircle is pi. So if I do this, that is half pi. Right? Mm-hmm. It's 90 degrees. We also just figured that out, didn't we? Like the very first thing we did right here was converted 90 degrees to half pi. So it's half of pi. All right, so what they've done here is they have divided pi into 12 equal pieces. So that means that 180 divided by 12 is 15. So, but that's also pi over 12 because it's divided into 12 pieces. So this is pi over 12. The next one would be 2 pi over 12, but 2 pi over 12, right? Because we're just counting 1, 12, 2, 12, 3, 12, 4, 12, 5, 12, 6, 12, which simplifies to 1/2. But this would be 2 pi over 12, but that simplifies to what?
Pi over 6.
Yep. So this is pi over 6. So 30 degrees is pi over 6. Then the next one would be 3 pi over 12, but that simplifies to pi over 4. The next one is 5 pi over 12. Wait, 4 pi over 12, sorry, which simplifies to pi over 3. And then 5 pi over 12. And then 6 pi over 12, which is pi over 2. So let's see, 60 is pi over 3. And this is 5 pi over 12.
75 is 5 over 12?
Uh-huh. And, oh, that's not 12, it's half. 90 is half pi. Which is pi over 2, but you'll hear people call it half pi. I call it half pi sometimes. Then after half pi, we got another 12. So that's 6 pi over 12, which makes the next one 7 pi over 12. The next one would be 8 pi over 12, but that simplifies. Not, you're close. 2 pi over 3. So 8 pi over 12, 4 goes into both. It's 2 pi over 3. So this is 2 pi over 3. And then 8 pi over 12, 9 pi over 12, which simplifies.
8 pi over 3.
No, 3 pi over 4, right?
There you go. And this is 10 pi over 12.
5, 6.
5 pi over 6. And then this is 7 pi over 12. And then pi would be 12 pi over 12, right? Okay, before we go continue on and do the 7 pi over 12 and then pi. Before we go do the bottom half, let me make sure you understand this. So,
wait, what? 7 pi over 12? Is that 165 was?
No, it's 11 pi over 12.
Okay.
I said 7, but it's 11. Okay, so since I already have this up here, let me go ahead and... So right now this is divided into half pies. But if I divide it like this, what is my pi divided into now? Geometrically?
Fourths.
Fourths. So this is pi over 4. That's 2 pi over 4, which is half pi. And this is 3 pi over 4. Right?
Yes.
Okay, they're also 45-degree angles. 45, 90, 45. Yeah? Okay. So I could divide it into, let's do, I'm going to take my pi, my whole pi, and I'm going to divide it into thirds. So this is pi over 3. This is 2 pi over 3. Really. And that's 3 pi over 3. Make sense? Okay, well, I could divide that into sixths. So this is pi over 6. This is 2 pi over 6, which is pi over 3. This is 3 pi over 6, which is pi over 2. 4 pi over 6, 5 pi over 6. It's just geometry. And this one is a whole 6 pi over 6, right? Everybody's good?
Mm-hmm.
Awesome. Okay, so now after this, we keep going. So now we're beyond pi, we're beyond 1, and we're into improper fractions because we've already made a whole, no matter what denominator we have. So if we keep going, 195, this was 12 pi over 12. So the next one's 13 pi over 12.
So where did we get the 12 from?
They divided, if you just look, these dotted lines, they divided it into 12.
Oh, okay.
So
They just chose that.
the radians can be different every time depending on how much is divided.
Yeah, yes. And the reason they chose 12 is because we have 3 special angles. When we made our chart, what are our 3 special angles?
30, 60, 45.
Yeah, 30, 60, and 45. And all of those can be made with 12ths. So that's why they chose 12, is because it gets them all, it covers them all. Okay, so this is 13 pi over 12. This would be 14 pi over 12, or
7 pi over 5.
7 pi over 6.
Yep.
And then this would be 15 pi over 12, which is 5 pi over 3. No, 5 pi over 4, sorry. And then, what is that? 13, 14, 15, 16 pi over 12.
Which would be 4 pi over, no, 8 pi over
No,
6?
4 pi over 3.
Okay.
And then 17 pi over 12. 18 pi over 12, which is 3 halves pi. And if you think about that, that makes perfect sense. That's a half pi, whole pi, add another half, is 1.5 pi, or 3 halves pi. Yes? Everybody good?
Hold on a second. You said 3 pi over 2?
Mm-hmm. Because each quadrant is a half of a pi. Half, 2 halves, 3 halves. This is 2 pi, since we're at it. It's also 0. It says 0 right there, but it's also 2 pi. Okay, so 7 pi over 12, and that was, 18, 19 pi over 12. 20 pi over 12, which is 5 pi over 3.
I feel like we're repeating, but we're not.
Nope. This is 7 pi over 4, because I just divided it in fourths in my head. This is 5 pi over 4, that'd be 6 pi over 4. This is 7 pi over 4, 8 pi over 4 is 2 pi. All right, so the next one up, so if you look at the order of how these go, it does the same every time. It's 12, 6, 4, 3, 12. So 12, 3, 4, 6, 12. These are mirror images of each other. So 12, 3, 4, what's supposed to be here?
6.
6. So if I had, this is 7 pi over 6. This would be 8 pi over 6. 9 pi over 6. 10 pi over 6. What's this one?
11 pi over 6.
And then last, this is 24 pi over 12. So this is 23 pi over 12. Now you can go fill all of these in if you want to. It doesn't really matter.